Hello everyone, my name is Adi Kurnia. I am PhD candidate in the Department of Chemistry of Chung Yuan Christain University. My advisor is Professor Chung-Der, and today I will be talking about my most recent publication titled Performance Comparison of 5 Methods Available in ImageJ for Bird Counting and Detection from Video Datasets. Bird migration has been an important factor in observing the implications of habitat loss, climate change, and human activity. And external conditions are known to affect the time, distance, and migration routes. And many bird researchers often share their findings through videos of bird migration and several points within their migration route to observe their population into a cloud-based website. And birds counting are important to help with this process. Well, there are currently AI-based tools to help in observing birds. However, they are relatively expensive and inaccessible for common peoples. Therefore, in this study, we are trying to test methods available in ImageJ as an alternative method to count birds. And this is the workflow. Of our study. So first, we procure the video from online sources. All of them are obtained from YouTube's, and the criteria of the video is that the first condition is that the birds are moving unidirectionally. The second case is where the birds moving in the field background, so there will be like trees or objects in the background. And the third is where birds moving multidirectionally, and the fourth case is where there are very high number of birds. And we will train the data in some method that we test, and we will collect the data using ImageJ. The method that we will test are TrackMate, particle analyzer, Watershed, Maxima, and trainable WEKA segmentation. All of them are available in ImageJ. And then we will do statistical tests using the mean regression, and we will also test the precision, sensitivity, and the F1 score calculation using Python. We will overlay the coordinates of the methods to manual pinpoint method that we do, and then we will calculate the precision, sensitivity, and F1 score from the overlaid coordinates. But first, before we process the image in ImageJ, we need to convert the videos to AVI format using virtual dub2. We use the build 44282 downloadable in the link we provided here, so the video can be accessed in ImageJ. Then we can open the video in ImageJ, and then we use the ImageJ version 1.54F. First, we convert the video to 8-bit, and then to remove the background, we convert the video to mask using the intermodes method using binary convert to mask, and then set the methods to intermodes. And background we set to light, but it depends on your video. But most of our video, all of our video is set to light. Then click OK. And this is the result example for the removal of the background. This is the original one, and this is the after you convert to mask. So the background will mostly be white. Next we will do the manual counting. And to count the birds and to extract their coordinates, we use the cell counter tool. You can just use the search bar to look for the cell counter tool, and to use it, after we click on the cell counter tool, we can click on initialize and then select the type of the object, and then you can start on selecting the objects. And to obtain the coordinates, we can click on measure. And these are the 5 methods that we will test that are available in ImageJ to help in bird counting. So first one is TrackMate. It is previously used for blood cell tracking and zebrafish, and we are trying to repurpose it for birds, as it should be possible to be implemented as long as the blob size or the bird size, the blob size we set is similar to the bird size. And for the particle analyzer, it was previously tested in Tetrahymena, and it can be used to count objects depending on their size or circularity threshold, but it was also used previously on birds. Next is the Watershed. This one is a bit unique because it is commonly used in cells to separate overlapping or connecting cells. The next is Maxima. It is used to count cells and objects depending on the difference of brightness. So maybe white object in the dark background or a dark object in light background. And this method is also used previously for bird counting. And the last one is trainable WEKA segmentation. And this image segmentation based on multiple filters. And it involves machine learning, which can be applied to similar images. First, I will introduce you to TrackMate. So to use TrackMate, we need to convert the image to 8-bit and invert the color, because the previous setting that we have is a dark object with light background, but here we need white object in dark background. And we can just use the search bar to look for TrackMate and do the settings here. We have a DOG detector for this study, and we set this diameter to 40 while the quality is set to 4 for the sample video that we provided. And for the tracking, we use Simple App Tracker for the tracker because TrackMate is meant for tracking, so we need to set the tracker here. And then we export the results to XML file to obtain the coordinates, because we need the coordinates to calculate the precision, sensitivity, and F1 score. And then we also plot and spots versus time to obtain the bird count. And this is the results. So this is the plot and spots versus time. We will see that there are how many spots or how many birds there are in the certain frames. And this is the XML file where we can get the coordinates and the birds that are in the time that we want. For example, this is in 0, it means that it's on the first frame of the video. Next is Find Maxima. So we use the Find Maxima tool available in the ImageJ pre-installed, and we just need to go to Process, click on Find Maxima, and we set the prominence to 10, and we will be able to obtain the count and centroid coordinates of the bird by setting the output type to list, and we will obtain the coordinates, the centroid coordinates of the birds. For the particle analyzer method, we use the thresholding using ImageJ threshold to highlight the objects. Here, you see that the objects is highlighted by red. We use the slider to move it so only the it only highlights the object, and then we set the size for the measurement. We set the size to 30 to infinity, but depending on your object, you can set it accordingly. And then just click OK, you will get the coordinates and the bird count. Next is the Watershed method. This method has identical process to PAM. However, we will apply the Watershed segmentation first, and then this method is used to segment the objects. The object should be in dark with on a light background, and it works especially well on overlapping objects and for overlapping or connecting objects. And to obtain the count results, please refer to the PAM process using the analyzed particles after the Watershed is applied. Next is the trainable WEKA segmentation, or the TWS. TWS is a plugin in ImageJ created by Arganda Carreras and company, and it works by combining a collection of machine learning algorithms with image datasets to produce image segmentation. And for trainable WEKA segmentation, it comes pre-installed in VG build of ImageJ. And this is the GUI of the trainable WEKA segmentation. Here is the training tools. It includes the train. This should be trained, but it already runs, so it reads stop now. You can toggle overlay, create result, get probability, get and plot result. And this is where you can apply, load, or save the classifier or save library settings, and etc. And here we can mark the object or background, then we can add the class. In this case, we put the bird in class 1, and then the background on class 2. So here the green one is the background, while the bird should be on red, and then we can click on train. But here, because we already click on it, it said stop. Here is the example for trainable WEKA segmentation result. So the label color called the labels are color coded according to their class. For the red is the objects, the birds, and for the green is the background. Then you can click on the save classifier, and the classifier can be used in the future to detect similar image or stacks by using load classifier and apply classifier. And then after you apply it, you can click on create results to show the segmentation result. Then apply the same workflow to count the birds and extract coordinates as PAM using analyzed particles. Our other endpoints, so we calculate the precision, sensitivity, and F1 score of the bird counting using the tested methods in Python. And we develop a hybrid code to overlay the extracted coordinates from the same frame and compare them to manual pinpoint. As the manual pinpoint might not be the exact centroid because of the human error, we add a distance threshold setting in the code. So this should be this should make the distance the pinpoint of the human and the pinpoint of the tools uh, to be recognizable with the tool. And the code will iterate through the coordinates list and match them with the manual pinpoint. It will try to only match one coordinate from each method to one of the manual pinpoint method. And here is the classification. So coordinates match with manual is called true positive. Coordinates exist in manual but not detected in tested methods is deemed as false negative. The coordinates exist in tested methods does not exist in manual is false positive. While if there are multiple coordinates exist within this distance threshold, the closest one is deemed as true positive while the rest is false positive. And this is the equation for the sensitivity, precision, and F1 score. For sensitivity, it's true positives divided by the total of true positives and false negatives. For precision, it's true positives divided by true positives plus false positives. And for F1 scores, it is 2 times precision, the double of precision times sensitivity divided by precision plus sensitivity. And for our code to work, for the script to work, we need to prepare the data accordingly. So after the coordinates are obtained, the coordinates need to be moved to a new Excel file, and the format is demonstrated here. So the first one must be the manual pinpoint, and this, you can put method 1, method 2, method 3, 4, 5. It can be like TrackMate, particle analyzer, find Maxima, Watershed, trainable WEKA segmentation, or you can mix the order, but you need to keep them similar for all the frames that you test. We only test around 10 frames. 1, 2, 3, 4. Yeah, 10 frames for our testing because manual counting is really tedious. And here we use the Python scripts, and the scripts work in 2 steps. The first one will overlay the coordinates obtained from all the methods on top of each other, and the second script will match the coordinates from the tested method to the manual pinpoint based on the distance threshold to obtain the aforementioned endpoints. This is the results of the phase 1 sample 1. We observed the movement of cattle egrets above the sea, and here's the overlay that I told you previously. And this is the result of the counting, how many birds in the frames, and this is the Deming linear regression to check if there is a similar number between the manual counting, which is the x, to the method that we tested, which is dy. The format will be similar for all the results in the next slides. So here we can see that the sensitivity and precision of the TrackMate is high, while particle analyzer have good sensitivity, but the sensitivity is not as high as the TrackMate, but their precision is higher compared to TrackMate. On the other hand, the Watershed compared to the others have the lowest sensitivity and the lowest precision. For find Maxima, they have like respectable sensitivity and also high precision compared to the other methods. And the F1 score, because it's calculated by calculating the sensitivity and precision, we can see that the F1 scores are also acceptable here, especially for the TrackMate and the Find Maxima. And for the Deming regression, even though Watershed is the closest to 1, but the sensitivity and precision and F1 score doesn't support it that well. So here I think the TrackMate works the best compared to the other methods. Next, in case 1 sample 2. Next, in case 1 sample 2, we observe the movement of goose flying above the water, and there's a background of trees, possibly a background of trees. And we can see that the overlay here, that the red one, which is the Find Maxima, seems to have some errors because of the background. Because for Find Maxima, you can only set the prominence threshold. You cannot set the size threshold or circularity or shape. So it's prone to misdetection if there is a similar colored object in the background, and we cannot really remove everything in the background. And here's the animal count. But even though the Find Maxima showed some errors, we can see that the Watershed seems to have lots of false positives compared to the control if we compare it to manual counting. And we can also see in the linear regression that the same profile happens. And here in the Deming regression, we can see that the particle analyzer and WEKA have negative slope, while the Watershed and Find Maxima have really high slope. And for TrackMate, even though it has high slope, it's the closest to 1 compared to the other methods. Now we can see the sensitivity. Even though the Watershed has the highest sensitivity, it also has the lowest precision. So it's not preferable, because we want the sensitivity and precision to be as high as possible. And here we can see that the TrackMate seems to have the highest sensitivity compared to the other method, and also the very high precision, which is preferable. And with the Deming regression showing the closest to 1, even though it's not perfect, it's not really 1, it is preferable compared to the other methods here. Next, we observe the movement of cattle egrets again with the background of trees in the above a forest. They fly above a forest, and similar pattern is seen on the overlay and the animal count. The Watershed really overestimates the number of birds, overcount the number of birds, while the TrackMate seems to be the closest one, and the Find Maxima seems to have high number of counting at the start, but at the later frames they undercount the number of birds, similar to the particle analyzer and the WEKA. And here we can see in the Deming linear regression, the TrackMate seems to be the closest to the control line here. And for the linear regression equation, we can see that TrackMate is the closest to 1, while the other methods seems to have negative or really high X value compared to the TrackMate. But for the sensitivity, precision, and F1 score, it seems that most of the methods doesn't really have high sensitivity or precision, except for the Watershed that has the high sensitivity at 0.895, but their precision is very low at 0.597, and TrackMate with the sensitivity of 0.683, but the precision is at 0.863. So their F1 score is also low at around 0.7, but it's still not preferable. So all of the methods are not preferable here, but with some settings or improvement, maybe the TrackMate can work better compared to the other methods. Next, in case 3, sample 1, we observe the movement of Chinese sparrowhawk. Here we can see again that the watershed, because it is usually used for cells, there is a possibility that it's not working well for birds. So that explains why it often overcount the number of birds. We can also see in the dimming linear regression, except for TrackMate and WEKA, it seems the other three methods works quite well in this case. And we can also see in the dimming regression that the TrackMate, particle analyzer, and find Maxima are really close to 1. Their slope is really close to 1 compared to the Watershed and WEKA. And for the sensitivity and precision, the TrackMate, particle analyzer, and find Maxima also has a very high sensitivity and precision values. Therefore, their F1 score are also very high. And the three of them can be used for counting in this type of image or video. We observe the movement of birds of this Ciconidae family, and here we also see again that there are lots of the TrackMate overcount, and here we also see the same profile. Well, the other methods seem to undercount because from the image you can see that they are prone to overlapping or connecting between each other. And here on the graph of the dimming linear regression, we can see that none of the methods seem to work quite well here. From our slopes, it seems that the watershed is the best compared to the other methods of TrackMate, particle analyzer, find Maxima, and WEKA, with a very high sensitivity at 0.892, but the precision is still quite low at 0.812. But the other methods seem to have the very high precision above 0.95, but their sensitivity is lower compared to the watershed. So in this case, maybe not all of the methods are suitable for this case because there are lots of connection and overlapping, so they cannot segment the birds perfectly. And the final one is Turnidae. We can see that there are really lots of Turnidae in this image, and it ranges maybe around 1,000 to 3,000 birds. And from the overlay, we cannot really say that there are lots of overlapping or overcounting by the watershed like previously happened. But in the animal count, we can see that the number of watershed is similar to the number of manual counting. Meanwhile, the other methods seem to lag behind the watershed here. So this is only the case where watershed seems to perform better compared to the other methods. And we can also see in the dimming linear regression. And here the equation is also the closest to 1 at 0.8638, with the sensitivity and precision at a very high value, and with F1 score at 0.955. Even though the TrackMate has the highest precision at 0.997, their sensitivity is a bit lower because at later stages of the counting, at around above this thresh point, or maybe above frame 80, because the number of birds are really high and their size changes. They get a lot smaller. TrackMate seems to have difficulty in detecting them and tracking them. So this is the summary for our testing. So for particle analyzer, it has size thresholding, which helps differentiate birds from unwanted background objects, but it has no segmentation capability, so it cannot separate connecting or overlapping objects, and it might need some experience and adjustments in setting the size threshold to obtain the best result. And for find Maxima, it is the fastest and simplest method to count birds, and it is unable to measure the object size, and there is no thresholding to differentiate birds from unwanted objects. But Next is Watershed. The segmentation helps to count connecting or overlapping small birds, but the segmentation algorithm is mostly not suitable for birds, and most of the time resulting in overcounting of the bird number, resulting in low precision. For TrackMate, it can be used to count birds with high precision and respectable sensitivity, but the difficulty in detecting objects if the size is dynamic, which is the last video, and it takes some time to process the video, which depends on the video resolution and duration. And finally, trainable WEKA segmentation is able to output similar results to particle analyzer from most of the tests that we have done for the cases that we have tested. But the difficulty in detecting objects with significant size differences, and there were also times when the segmentation actually increased the size of the objects and creating a pseudo connection and reducing the bird count. And it also takes time to train a model. The pseudo connection can be seen that uh, in the fourth case or the fifth case, where the bird count is on the fourth case and the case 3 sample 2, where the bird count is really low compared to the other methods. So the conclusion is that in this study we are able to provide several alternative methods for bird counting, and we also have provided a script to ensure the precision and sensitivity of our methods are reported in the manuscript. And through this SOP, we hope that the readers are able to replicate our method, and we are also welcome you if you have questions to contact us through the provided contact information. So that's it for my presentation today. Thank you.